Hi, this is Group Black Magic. We'll be addressing our NLP final project with question generation and question answering. So now let's first go to the overview. For question generation, we first pre-process the article with NeuroCoref and determine the question type, and finally, ask either binary questions or WH questions. For question answering, we first pre-process the questions, then we parse them into trees with Stanford Parser to find a question type, and then we use different techniques to answer different type of questions. So now let's go to the question generation. First, we will go over how binary questions with transitive verbs and intransitive verbs are generated. For VB binary case, our first step is to find the subject. In this example, the subject is the John Hines, where Hines can be detected with the tag NSUBJ and John is the compound. Our second step is to find the verb and convert it to questions based on its tag. For example, if the verb is tagged VBD, we'll convert it to a did question. The rest of the sentence remains intact. We'll convert it by rearrange the word order and add a question mark at the end. Because in this example, went is in past tense, we lemmatize the verb to give a grammatically well-formed question. Now, auxiliary binary questions. For sentences that contain link verbs, auxiliary verbs, or modal verbs, we generate binary questions for these sentences in slightly different ways. Our first step is to find the subjects, which is John Hines. Next, we find the root auxiliary verbs, and the rest of the sentence remains intact as well. We convert it by rearrange the word order and add a question mark at the end. Because in this example, there is a not in the intermediate step, we also remove the negation word before returning the final results. In the ranking step, we'll rank no questions higher than yes question. Now for WH questions, we broke it down into 3 categories. We'll explain how what and who questions are generated first. We find subjects and root verb of the sentence. Then we detect if entity tag exists in the sentence. And for tags such as org, for organization, we ask a what question. If the tag is per, for person, we raise a who question. Secondly, we will introduce how to generate the where questions. Similarly, we find the subjects and the root verb. We find the preposition and the entity tag, organizations, GPE, LOC in the sentence, and rearrange the sentence and lemmatize to ask a where question. Last but not least, the why questions. Our why questions is asked whenever we detect the because in the sentence. We detect the tense by looking at the tag of the verb and lemmatize the verb before we return the final question. Now, ranking. Our question lists are generated in the following steps. First, we generate the perplexity of each question by building a trigram model on development set and calculate the perplexity of generated questions. In our ranking step, we give why questions the highest priority. Second tier questions are binary questions with answer no, followed by other questions with smaller perplexity. We return the ranked questions as our final output. Now let's go to the question answering. First, we pre-process the questions and the article. Then we use Stanford Core NLP parser to parse the questions into NLTK trees and determine the question type. The tree label SBRQ means a WH question, and tree label SQ means a binary question. Since both binary questions and WH questions has a binary form, and for binary questions is the question itself, but for WH questions is the question without the WH form, which is the boldface here. We then converting this binary form into narrative form, making it better in comparing questions with the article sentence. For answering binary questions, we use the fuzzy wuzzy score. If the score is above certain threshold with no negation, we return yes. If there is an odd number of negation, we then return no. However, if the score is below the threshold, we then check if all the POS tagging and the word pair match, and then do the negation catching. Now there are two steps for answering the WH questions. First, we use the cosine similarity to find the best matched sentence. Then we use NER tagging to find the most concise answer. Different NER tags are associated with each question type, and we therefore look for different attributes respectively. For example, to answer the where questions, we look for NORP, FAC, GPE, LOC, ORG. These tag within the sentence and return that part of the candidate answers that was passed into the function. There are cases where specific locations are not tied with these tags. Therefore, we also check within the sentence if there are prepositions such as in, at, and return the noun following the preposition.